Welcome to the lesson on Introduction to Lines and Angles. At the end of this lesson, you will be able to define the basic terms related to lines and angles. You will also be able to recall the definitions of different angles based on their measures and classify different pairs of angles formed by two intersecting lines.
Dad, look at the stars. They look like points.
Can you spot the brighter ones?
Yes, and if we join them, it becomes a line.
That's right.
A line is a collection of points along a straight path. A line has no endpoints.
A line can be extended indefinitely in both directions. Let's call this line AB. It is denoted by a double-headed arrow. Sometimes lines are also denoted by small letters L, M, N, and so on. A part of a line that has two endpoints is called a line segment. Let's name this line segment EF. It is denoted by a bar. And a part of line with one endpoint is called a ray. Let's name the ray PQ. It is denoted by a single-headed arrow. All the points that lie on the same line are collinear points. Consider the two rays AB and AC originating from the same point A. This formation brings us to an important term in geometry, the angle. The rays that form the angle are called the arms of the angle. The point of origin or the intersection is called the vertex of the angle. The size of an angle is measured in degrees. We will now learn more about angles. First, let's quickly review our understanding of the different types of angles based on their measures. We'll use a clock for this activity. Let's assume the two hands of the clock represent two rays. Now, let's note down the measure of angles at different times. At 2 p.m., the angle formed is 60 degrees. An angle that measures less than 90 degrees but more than 0 degrees is called an acute angle. When it is 3 o'clock, the rays form a 90-degree angle. A right angle is an angle measuring 90 degrees. It is formed by the intersection of two perpendicular lines. Similarly, at 5, the angle formed is 150 degrees. Angles greater than 90 degrees but less than 180 degrees are known as obtuse angles. Now, let's see what angle is formed at 6 o'clock. This angle is equal to 180 degrees. An angle that is equal to 180 degrees is called a straight angle. Let's measure the angle formed by the rays when it is 8 o'clock. To measure an angle greater than 180 degrees, first take a straight angle and then add the remaining angle to it. Now, when you measure the angles, it is 180 degrees plus 60 degrees, which is 240 degrees. A reflex angle is greater than 180 degrees but less than 360 degrees. Before moving on, let's summarize the definitions also shown on the screen. Consider the angle ABC. Pass the ray BD through the vertex such that it divides the angle ABC into 2. The two angles that are formed are angle ABD and angle DBC. These angles have a common arm BD and a common vertex B. Two angles are said to be adjacent if they have a common arm and a common vertex. Observe the adjacent angles ABD and DBC. The sum of these angles is equal to 180 degrees. Such a pair of angles is called a linear pair. Here the common arm is BD, and the non-common arms BA and BC form a straight line AC. Let lines AB and CD intersect at a point O. At the point of intersection, four angles are formed. On measuring the opposite angles, you will find that they are equal. Such angles are known as vertically opposite angles. Two angles are said to be complementary if their sum is 90 degrees. They may or may not be adjacent angles. Two angles are supplementary if their sum is 180 degrees. They may or may not be adjacent angles. Just as we have different types of pairs of angles, we have different types of lines too. Look at these lines. You can see some lines passing through each other while others are not. Let's look at these set of lines. They are crossing one another at a single point. Such lines are called intersecting lines. Intersecting lines can be defined as two or more lines that meet at one point. Now, let's look at another set of lines. They neither meet nor cross at any point. Such lines are called parallel lines. Parallel lines can be defined as lines on the same plane that never intersect. Son, now have you learnt how the dots have transformed into so many lines?
Oh yes, that's why I said nature never ceases to amaze me.
Now that you have the basic understanding of intersecting lines, let's prove a theorem. The theorem states that when two lines intersect each other, then the vertically opposite angles are equal. Let lines AB and CD intersect at a point O. We have to prove that angle AOC is equal to angle BOD, and angle BOC is equal to angle AOD. Since CD is a line, angles AOC and AOD form a linear pair, and thus their sum is equal to 180 degrees. Similarly, AB is a line, thus the sum of angles AOD and BOD is equal to 180 degrees. Now, from equation 1 and 2, the sum of angles AOC and AOD is equal to the sum of angles AOD and BOD. On equating, we get angle AOC as equal to angle BOD. Next, we need to prove that angle BOC is equal to angle AOD. Again, since AB is a line, the sum of angles AOD and BOD is equal to 180 degrees. Similarly, CD is a line. Therefore, the sum of angles BOC and BOD is equal to 180 degrees. Now, since the RHS of both equations 1 and 2 are equal, on equating the LHS of both the equations, we get angle AOD, which is equal to angle BOC. These are vertically opposite angles.
We have learnt to find the angle between different lines that intersect. Let's recap. consider the two sets of lines as shown. We observe that the first set of lines meet at a point O, and the second set of lines never meet. Such lines are called as parallel lines. Parallel lines are defined as the lines which are separated by equal distance throughout and which never meet. One such example of parallel lines in our day-to-day life is a railway track. Let's learn the procedure to draw parallel lines using perpendiculars. Draw a pair of parallel lines which are 5 centimeters apart from each other. First, draw a line using a scale. Label it as AB. Draw a line PU of length 5 centimeters perpendicular to AB as shown. Similarly, draw another line RV of length 5 centimeters perpendicular to AB. Using a scale, draw a line joining the points U and V. Thus, obtained line XY is the line parallel to AB, which is 5 centimeters apart from it. Now, let's look at drawing parallel lines using a set square. First, draw a line using a scale. Label it as XY as shown. Now, place a scale perpendicular to set square along the line XY as shown. Keeping a firm hold on the scale, move the set square upward as shown. Now, remove the scale and draw a line AB along the set square. Thus, AB is the required line which is parallel to XY. If we consider a line PR which is inclined at 55 degrees as shown, it is difficult to draw a line parallel to PR using a set square. Let us now look at drawing a line parallel to an inclined line. To draw a line parallel to AB, first measure the angle BAC using a protractor. Now, with the same measurement, draw a line A'-C' as shown. Therefore, the line A'-C' is the line which is parallel to AB.